Okay, 5.2 worksheet. Um, in 5.2 in the Xi book, it talked about several different terms that we're going to define, and some of them are really tricky. So anyway, let's just do this. An experiment. So an experiment is something that you do to people. Yes, that is how we're going to define it. So something researchers do to people. And the thing that they do is called a treatment. So the thing that is done to people is called a treatment. And in the medical field, treatment makes perfect sense. You get antibiotics and you don't. Or you're going to get blood pressure medicine, you're going to start exercising, but it is something that the researchers ask or make people do. They're trying to engender some sort of change. Okay? And that is in direct opposition to an observation. An observation is simply asking questions. So there is no treatment in an observation. Whenever possible, we want to do experiments. Experiments are far more valuable than observations. A lot, maybe most of the time, observations are not really very useful. And we'll get into that a little bit more. However, sometimes experiments are impossible or at least not ethical. For instance, Jacob, see this pack of cigarettes? Smoke one of these every hour for a couple years and then we'll see what happens. Okay? That doesn't really make sense. So if you want to know what are the effects of smoking, you could make mice smoke or rats or guinea pigs. How do they hold the cigarette? Well, they don't. You just burn tobacco and blow it into their cage, and they have no choice but to breathe it in. Yeah. No, secondhand smoke means it went in somebody's lungs and then out, and then you breathe it in. So we do know that smoking is bad for humans. So sometimes stuff that works on animals doesn't work on humans. It's really weird. Like you would think that it's universal, but that's not at all true. We have found all sorts of weird things that happen to mice and rats, and then when we try to transfer it over into people, it just doesn't work, or it works in a different way. So if we want to know the effects of smoking on the human body, we're going to have to talk to humans who smoke. It's not ethical to make people smoke and then see what happened to them. So sometimes observations are all we have. But whenever possible, we want an experiment. And as a general rule, experiments are trustworthy, observations not so much. Okay? So, when we do an experiment or even an observational study, we want to do what is called random sampling and random assignment. And they're similar, but they're different. Okay? Random sampling means people for the study are selected randomly. So random sampling means when we choose people to join the study, the choice of who gets in is random. Now sometimes that is not possible, right? Sometimes you have to select the people you want because that's all there is. Like you want to know does this drug work on people who have lung cancer? Well, you might only have 8 people that have lung cancer, and so you pick all of them. And were people randomly selected to be part of the study? No, they just happened to be convenient and we threw them in. So the way I like to think of this is, this is how people get in. Is the process of joining random? Okay, and in addition to that, what do we mean when we say random? Well, here's what we mean. Every person has an equal chance, not change, chance of being selected. Okay, so if I wanted to know something about the population in every county and I only go to people that live in Cleveland, Elmo, and Huntington, and I randomly pick the people in Cleveland, Elmo, and Huntington, is that an example of random sampling? No. Did a person in Farron have the same chance of being selected? No. What if everybody's name is listed and I take the first person and then every 10th person after that? Is that random sampling? Did every person have the same chance of being selected? No. So it gets kind of hard sometimes to figure out, is this random sampling or is this not random sampling? But the rule of thumb is, look at a random person. Do they have an equal chance of being selected? Okay, random assignment occurs after random sampling has been done. So in your experiment or your observation, you're going to be focusing on a variable which divides people into specific groups. So in random sampling, once, okay, let's do it this way. Random assignment is randomly selecting people in the study. Let's say assigning. Sorry, you guys can't do that. Randomly assigning people in the study to a specific group. So random sampling is the process of people joining the study. And then inside the study, we're going to give some people a treatment and some people no treatment. So the process of putting people in treatment or not treatment must also be random. And it follows the same rule as random sampling. Does every person have an equal chance of landing in either group? So if I'm testing 4 medications and I randomly pick people in Emory County, and the first 25 people who show up get treatment A, and the next 25 people that show up get treatment B and C and D, that would be random sampling because the people in the study were chosen at random, but it would not be random assignment because the groups within the study were not randomly assigned. And the reason that you want random sampling is you need the people in the study to represent the population as a whole. So if you were measuring height at Emory High, and all you did was sample the people that are in the Spartan Center after school, you're probably going to talk to a lot of basketball players. And do basketball players represent this school as a whole? No, thank goodness. Will's not even here. Whatever, we can still make fun of him. Okay? And then once you have selected people to be part of the study, if there is any need to break them into groups, those groups need to be randomly assigned. And sometimes that's impossible, right? Sometimes people put themselves in their own group, and there's just nothing we can do about that. Okay. Get rid of all this. All right. What aspect of a study allows us to determine cause and effect? Do you remember this from 5.2? So we want to know, does A cause B? So how do we decide if A causes B? Well, we're going to set up either an experiment or an observation. And what aspect of this, whether it's an observation, experiment, random sampling, or random assignment, allows us to determine cause and effect? We not remember? Okay. I was afraid this was going to happen. So let me pull up the Zybook. They say it so much better than I can. All right, 5, 2. Okay, so let's go to. I don't think that's even right. Okay, random assignment deliberately uses randomness in the study to provide the potential for concluding cause and effect. And then up here it says, random assignment gives us the ability to draw cause and effect conclusions because it ensures that the treatment groups have similar characteristics. So once you've chosen people for your study, so let's say I randomly get 50 kids at Emory High, and I want to teach them a better way to study for a test. If I randomly split them in half, and half of them get my new way of studying for a test, and the other half don't, because I randomly assign them to the group, the treatment group should be similar in makeup to the non-treatment group. So are the people inside the treatment group all going to be the same type of people? No. So when okay. So here's my population, okay? And I randomly go through and I grab 50 kids. Those 50 kids are going to be a mix of all different sorts of people. So I'm going to split them into two 25 people groups. But if I do it randomly, then the overall makeup of this group should be roughly the same as the overall makeup of that group. Even though the people in the group are different, we want a mix of everybody. And the only difference between these two groups is treatment and non-treatment. So if I randomly assign here, and I give one group the treatment and one group the not treatment, that helps me say, oh, the results here are different than the results here, so the treatment must have had this effect. The treatment caused an effect. So that first question, what aspect of a study allows us to determine cause and effect? It would be random assignment. Okay, the second one. What aspect of a study allows us to ensure that treatment and control have a similar makeup? That is also random assignment. So if we look up here, this is random sampling, and this is random assignment. Does that make sense? Okay, so if I do random assignment, then these two groups should be about the same. And if those two groups are about the same, then I should be able to say that A causes B. Now, there are some exceptions to that. Sometimes we do an observation and we find out that A and B are correlated, but they don't actually cause each other. But we need to do random assignment. Okay? What aspect of a study allows us to use results as a generalization of the population? That's going to be random sampling. All right. The idea is this. If I choose people at random, this group is smaller than the population, but it should look pretty similar, right? The average height should be about the same. The average age should be about the same. The average income should be about the same. The standard deviation of all those things should be about the same, okay? And then I split them into treatment and control, and I find that treatment works. Well, because this group is so similar to that group, and this group is so similar to that group, that allows us to say A caused B, which applies to this group of people, which applies to that group of people. So if your subjects are chosen at random through random sampling, then we can use our sample to make estimations about the population as a whole. Okay, does that make sense? Now, there is one more piece of this. Cause and effect really only applies with experiments. Okay? So if you want to know, does smoking cause cancer? And all you do is run around and ask people, did you smoke? And they say yes, or they say no. And I write all that down and I look and I say, wow, the smokers got cancer way more often than the non-smokers. Does that guarantee that smoking causes cancer? No, because it's an observation. Were the people randomly assigned to treatment or control? What was the treatment? Smoking, right? Did I tell people to smoke and tell people not to smoke? No. So, did they put themselves in their own groups? Yes. So, random assignment did not happen. So, if these are the smokers and these are the non-smokers, did my subset of people get assigned randomly to treatment or control? No. So it is random assignment that allows us to say cause and effect, but it is virtually impossible to have random assignment when you do an observation, right? Because people choose themselves whether to smoke or not to smoke. And why is that an issue? Well, are smokers categorically different from non-smokers? Probably, right? Are the people who smoke more or less likely to do other risky behaviors? Probably more, right? So if they're different in their choice to smoke, they're probably different in other choices. And because of that, we cannot trust cause and effect. So it is random assignment that allows us to do cause and effect, but almost universally, you cannot have cause and effect with an observation. You have to do an experiment. Now, again, sometimes experiments are unethical or impossible, but that's the best we can do. Okay? So if it's an observation, most of the time we do not say A causes B. We just can't, because we had no random assignment. We can do random sampling, but we cannot do random assignment unless we have an experiment. All right. Number one. So in each scenario, determine if it represents an experiment or an observational study. Then determine if it is random sampling and or random sampling and or random assignment are used. Number one. A researcher wants to study effects of a new teaching method on student test scores. They randomly select 50 students from a school and randomly assign them to either the new teaching method or the traditional method. Is that an observation or an experiment? Experiment. Are we doing anything to the kids? Yes. And that something we are doing is called a treatment. Okay. Does that involve random sampling? Did the kids get into the study randomly? Yes. Okay. And is that random assignment? Once they're in, were they randomly selected to be part of a group? Yes. So, can the results be used to represent the population as a whole? That is asking this question here. Does this group look similar to that group? Yes, because of random sampling. All right. And then the next question, can the results be used to determine a cause and effect relationship? Can we say the new teaching method works better than the old teaching method? Yes, because we randomly assigned the people in the study to different groups. So because of this, we can say cause and effect. Okay. Number 2. A teacher divides her class in half according to academic performance. The top half performers are taught a lesson using visual aids, while the bottom half are taught the same lesson without visual aids. All students are then given a quiz to assess their understanding of the concepts of the lesson. Observation or an experiment? Experiment. Is it random sampling? No, why not? Who got in? No, who got selected to be part of one of the groups? Everybody. Is that a sample? No. So either she wanted to know the effect on those particular kids, and that's the population, or she wanted to know if that would extend to the rest of the class, of the rest of the school. But in either case, it's not a random sample, right? Were kids randomly assigned to that classroom? No, they're not. So it's not random sampling. Is it random assignment? Did every kid have an equal chance of being in the first group? No. Did they choose their own groups? Sort of, essentially. And we would actually say yes. Did their actions put them in a group? Yes, it did. So it is not random assignment. So, can the results be used to represent the population as a whole? And we do this all the time, right? Can the results of kids in this class be generalized to all kids in the school? No, they can't. And yet we do that all the time in education. Okay? Can the results be used to determine a cause and effect relationship? Can we say visual aids are better than non-visual aids? No, because we did not have random assignment. Are the kids who got visual aids categorically different from the kids who did not? Yes. The kids are different, which means we can't trust the results. So even though it was an experiment, it's totally worthless. It doesn't do any good. Okay. Go for it. You have the rest of today to answer those questions.